Welcome to E-Padasala PG program for computer science students. Today we will be looking at I/O interfaces with 8051. So in this lecture we will be discussing about the LCD display and functions of its pins. Then how to interface LCD with the 8051 will be discussed along with assembly code, and we will discuss about keyboard and its keys, how it has been interpreted with 8051 will be discussed, and the interfacing of keyboard with 8051 is discussed with the help of assembly code. So in this LCD is a liquid crystal display. It is used for displaying the informations which we wanted to give as an output from 8051 for running a particular application. So as we know that 8051 is a chip where we do not have any input output devices explicitly. Though we have a interfacing ports, there is no explicit input output devices are there with your 8051. So now the liquid crystal display is used to display the informations which has been generated from 8051 as an output. So for that particular reason we will be using this simple display model, which is nothing but a LCD. Here the LCD will display numbers, characters and the graphics. So now how we will be connecting the LCD with microcontroller is one task. Another one is what are all the commands the LCD will receive, so that what it will do, and how we can inform the information to be displayed from 8051 to LCD. That also will be seeing in the next slides. So now you just see that this LCD is a 14-pin liquid crystal display, where it looks like a display where the panel will be in a position to hold two lines, where this LCD is having 14 pins. In this, the VSS and VO pins, VDD pins are for positive supply and ground supply, and this VO is for contrast adjust. By adjusting the different voltage given at VO pin, the different contrast will be adjusted, where the ground pin as well as the power supply pin is also provided. Then the register select pin is also there with your LCD. So which will say that the register select signal will say that whether we will be sending a command to LCD or we will be sending a data to LCD. So this is discriminated by sending either 0 or 1 to RS of LCD. Then read bar write select signal from LCD, and E is one which is for enabling the LCD, where we have DB0 to DB7 8 bits of data pins, where 7 to 10 is the lower order 4 nibbles, and 11 to 14 pins is the upper nibble data pins. So you just see that the different variety of pins which is available with your LCD. Here you just see it is available as a pins 1 to 14 on one side, on top side. Here another one LCD where 1 to 14 is given in the down side. Sometimes the pins is also connected in the sidewise also 1 to 14. So now you just see that these are the pins which are all very important when you are looking at your LCDs. While you are configuring, we have to look at these pins properly and we have to connect it with your 8051 so that it will be getting interfaced. So now as I told you, the LCD is having different commands. So if I am sending a particular value to value as a command to LCD, it will recognize what it has to be done if it has been given as a command over there. So these are the hex codes which will be interpreted by LCD to recognize these are the commands. See, when you are looking at display, there always we need to clear the screen. Sometimes we have to go to top of the screen, sometimes the cursor has to be decremented or incremented from its position. So, all these things can be done by sending this kind of comments to LCD. See, the comments is given as data to LCD. Data in the sense I can send a hex code of 38 to LCD, which indicates that I will be providing 2 lines. The display is of 2 lines, and 5 into 7 matrix display is initiated for displaying. And if I am looking at 8, if I am sending a hex code of 8, then it will say that display off and cursor off. If I am sending it something like 1, then it clears the screen. So, if I am putting a 2, then it goes to returns to home. So, from the position, if I wanted to decrement the cursor, then I will say that 4 is the hex code I have to send. So, that way if I wanted to shift the display right, then I will send a command as 5 to LCD. So, these are the hex codes which has been sent as a command to LCD to understand these are the things to be done. So, now this is how we will be interfacing your 8051 chip physically with LCD. Here the P1 is the port which is used as a data port which is connected to LCD. As I told you, it has 14 pins where D0 to D7 has data pins which is connected to P1 port 1 from 0 to 7, where this RS port register select is connected to P2.0 and read bar write is connected to 2.1 port pin 2.1, and this enable pin is connected to pin 2.2. So, and we know very well this LCD display requires 5 volt supply which is connected to VCC pin, and VSS is grounded, and this VEE is for contrast adjustment. So, when I am looking at we need to be very careful that when I am writing a code, I should remember that my P2.0 is connected to register select and P2.2 is connected to enable and P2.1 is connected to read bar write. So, based on that only I have to write a code to interface this LCD with your 8051. So, when you are looking at the writing a code to display characters on LCD, how we will be doing it, that is very important. So, now this is a sample assembly code to display characters on LCD. So, here is the information there. If I make RS as 0, then register select is 0, then the LCD understands that it receives comments. If I am making RS is equal to 1, the LCD understands that it is getting a data. And if I am sending a high to low pulse, remember there is no high pulse or low pulse. I need to give one full, I mean it is like a one cycle, high to low pulse or edge. Maybe I will say that high to low pulse has to be given to E pin to enable the LCD display. So, these are the primary setups which we have to done with your LCD before sending the data to display the things. And another one thing which we need to recognize is, if I am sending a comment or a display to your LCD, where the time, each and every time when I am sending a command, the LCD needs a time delay so that it processes that particular command, or if I am displaying a data that has to be displayed. So, always there is a time delay followed by the command or the data to be displayed. Now, this is a sample code where org0 it starts at 00 location. Now, move a hash 38. So, this hash 38 I am sending it as a command to this particular LCD. So, with the command says that LCD should have 2 lines display 5 cross 7 matrix. So, this has to be informed to the LCD. For that I am calling one particular subroutine which is for doing this particular task. When I am looking at command write, you just see that I have to make that first move P1 to A. Whatever be the data I have written at A is moved to P1 first. That means the data which is connected to your data line, then clear P2.0, RS is equal to 0, so that it indicates that I am sending a command. Then clear P2.1, which makes the read bar write is 0 to write. That means I am sending a data to the LCD to write. That is the idea behind making clear P2.1. Then set B P2.2. So, the 2.2 is connected to E line. Now, this becomes 1. Again I am clearing it so that it becomes 0. So, E is getting 1, after that 0, that means high to low pulse is given to E, and RS is 0 and right line is 0. So, that I have made the setup to recognize that particular command. Now, it is written. If I am putting a subroutine written, it comes to the previous thing. Now, the command write is written. Now, A call delay. So, now as I told you, each and every time I am sending a command, I need one delay which has to be given to the LCD to recognize to do that. So, the delay routine which we have written over here is for, this is the delay routine where R3 is moved with 50, R4 is moved with 255. First R4 is DJNZ R4 here, so that it decrements because it is a nested loop. If R4 is 0, again R3 is getting decremented for one time. So, 50 into 255 times the loop is getting rotated, so that by the time no work is done, which is nothing but it generates a delay, so that the LCD will recognize the command and it processes it. So, now we just see that the delay combined with command write makes the system to recognize this particular command, and it makes that 2 lines display with 5 cross 7 matrix. Now, I am sending move A comma 0E. So, display on and cursor on has to be sent by looking at this. Again I will call command write. So, which in turn makes again the whole procedure like RS is 0 and E is high to low, and write is also given. So, then there is a delay is called, so that these 3 things together to make the LCD to make display on and cursor on. Again move A equal to hash 01, it clears LCD. Now, this A content by calling A command write, which makes the A content is moved to P, the data pin, and it has been executed as a command, and there is a delay is called. Then again move A comma hash 6. This makes shift cursor right. The cursor will be shifted to right side, and again I have to call command write. Again I have to call a delay. Then move A comma hash 84, which says that the line is, the cursor is at line 1 and position 4. And again I have to write this command. So, A call command write, and there is a call delay is given over there. So, now you just understand that this is the setup we made it to make the LCD to display characters. So, here comes what we will be displaying it in the LCD. Now, move A comma hash n. Whatever be the character I wanted to display, I can move over here. Here I wanted to display n. So, the n is moved to A. Now, A call data write. Now, it is the data write. Now, we just see that it is not command write, it is data write. Now, we will see what way it is different from command write. So, this data write subroutine, when I am calling it, again the A content, which is nothing but your n, which is moved to your P1 port 1. Then set B 2.0, which is nothing but I am making RS is equal to 1. This is the difference between these two routines. So, if RS is equal to 1, the LCD will understand that it is going to receive only data. Then clear P 2.1, it makes write to get something to be written, and set B E is equal to 1, then E is equal to 0, and there is a return. So, that it comes over here. Now, the data is transferred to P1. This has to be written onto the LCD, so that I am calling a delay. After that A becomes O. Now, I wanted to, already I moved n, the cursor position is going to the next position. Now, the cursor is now displaying O. Now, A call data write, there again I am setting it, the whole thing is getting called. So, now I will be sending the data, I will be making RS is equal to 1, I am making write is equal to 0, E is equal to 1 and 0, high to low pulse. Again I am calling a delay, so that this particular 1 is getting written over there. So, after that I made it something like again S jump again. So, it has been looking at the indefinite loop, so that whatever be the data I wanted to display can be displayed with my LCD by looking at this kind of sequence has to be written over there. So, finally at the program end. So, this shows that each and every time when I wanted to send data to LCD, each and every character I need to follow up, this data write routine has to be run, there is a delay also has to be written. So, before doing all these things, we have to make the system has to go through a primary setup for LCD to be initialized, which has been done through this kind of setups. So now we will go ahead with something, see this has been initiated, how we will be interfacing LCD with 8051 controller. Now sometimes we wanted to see that whether the busy flag is there or not. If the busy flag is there, then it should not be in a position to write. If the busy flag becomes 0, then it has to write. Now I just connected the busy flag with P1.7. So the port 1.7 is connected with the busy flag, so that by looking at that particular one, I will be in a position to understand that whether I am busy or not. Based on that, I can write it. Otherwise, it will be the similar one which we have done it. So remember that first I made it move a comma 38, which makes 2 lines and 5 cross n. Again it a call command which writes, the command is written over there. Again by moving 0e as a command, 0e as a data and command write, so that this will be LCD is on, cursor on. By sending 01, it clears the LCD. Again I am sending 06, so that the cursor to write, and by sending the 86, which makes the position line as 1 and position as 6, so that I can place my cursor at whatever be the position I wanted to have it. Now I move A again, I call data display. Now I move 0, I call data display. So when I am doing this particular one, you just see that when I am calling the command line, it checks for whether the LCD is ready or not. So this is the difference between the previous program and this program. By looking at the busy flag, just see that a call ready is the routine which is called inside this command write. If I am calling a call ready, just I will come over here, I will check that set B P1.7, which makes the P1.7 is the input port where the busy flag will be checked. Now clear P2.0, that means the RS is 0 and set B 2.1, write is 1, so read the command register, because this is 1. So now it becomes a read. I need to read the information from LCD, because of that this becomes 1. And now set B P2.2, that means E is 1, clear P2.2, which makes E is 0, so that high to low pulse. Now I am looking at what is the bit of P1.7, JB 1.7. So jump if the bit occurs, otherwise you have to return. If I am saying that the bit is equal to 1, then it will come to this back. So that means the busy flag is there. If P1.7 is equal to 1, I will say that it is busy. So again and again I have to go through this particular procedure till I am getting a 0 at P1.7. When I am getting a 0, it comes down. That means the busy flag is off, so that the system is ready to do the job. So if I am thinking that it is ready to accept, then I will go through whatever be the data I wanted to send from A to P1, and I will be clear, I will be setting up RS is equal to 0, W is equal to 0, E is equal to high to low, then I will be in a position to write that particular one. So when you are looking at the data display also, I will call first the ready routine. So A call ready routine will checks that is there any the busy is there. The busy flag I will be checking up P1.7 is equal to 1 or 0. If it is 1, I will be rotating over here. When it is 0, it comes to return, so that I am just reading the data from A and I will be writing it in my LCD. So this is a procedure with which slight modification with the previous procedure, which makes that I will be checking whether the LCD is ready to receive or not. Based on that, I will be sending a data from my 8051. So when you are looking at a data sheet, I will be having something like you just see that E should be always 0 to low to high, as well as your read write is 1 to make it you wanted to read it, and RS is equal to 0, so that it enables. So when I am looking at that, RW is equal to 1 and E is equal to low to high and RS is equal to 0, which makes the platform. If the data is ready, then I will be in a position to either read or write based on what is the signal I am giving it on my read bar write. So you just see that this is for write, LCD timing for write. So now you just see that E is low to high, RW is low. This is the difference between that side, W bar, because of that this becomes the low, and RS is equal to 0. Then if the data is ready, so by the time only it starts writing the informations. This is the timing diagram which shows that how much is the delay required to either read or write with your LCD displays. So when you are looking at this is something like no need to take the data from the hard coded things. You can read it from different location. From there onwards you can move the data and you can write it in your LCD. That also can be done. This has been explained or demonstrated with this particular code segment, where move dptr hash mycom. So, the mycom is nothing but this is the address space where I wanted to give that particular address to this particular one. Now, clear A move C, because I am reading it from code. So, because of that move C and external memory A comma A at dptr. Now, I have read the command at maybe this is my mycom. So, db is first 38H, then 0E and 01, 06, 84H and 0. So, my command statements are written continuously from starting from this location, mycom location, incremented one after one, and I have written till I am getting a 0. When I am writing my data with my external memory, maybe hello is the word I am writing it, H is in one location, E is in one location, that way I am writing it, and it is followed by a 0. So, the 0 indicates that there is a data is over. That is what we are trying to communicate over here. Here just see that first I have read the command from dptr, I have called the command write, again I have called the delay, so that the LCD is received the first command, which is nothing but 38H. Okay. Then increment dptr, which in turn goes to the next data, so that it it gets the data, and this 01 is for clearing. So, that way I am reading all the command lines, each and every commands I will be reading it from my external memory by making it increment dptr and move C A at A comma at A plus dptr. So, that way I am just reading all the informations, the comments, and it has been burnt with my LCD, so that the LCD is getting ready to receive it. So, once I am getting a 0, that means the whole command is over. Jump on Z, JZ is jump on 0, send data. So, it comes over here. So, once it comes to send data, move dptr my data. So, my data is this particular data address which has been given over there to dptr. Now, clear A, whatever be the data which is available over there is read through move C A comma at A plus dptr, and A call data write. This is nothing but you will be calling data write. Instead of giving rs is equal to 0, now I will be making it this as 1, otherwise it will be the similar as my command write. I will be calling my data write, after that I will be delaying it, again I am incrementing the dptr, I am going over there, I am doing it till I am getting a 0 over there. So, once I am getting a 0, I have come down and I will be making a indefinite loop. This is the way I will be in a position to do my LCD connections. So, the next one which we wanted to make it as the input interface, which we wanted to make it with 8051 is nothing but keyboard interface. So, when you are looking at keyboard, here I will be constructing the keyboards which is like a matrix of rows and columns. So, when I am looking at the matrix of rows and columns, in the sense if I have a 4 rows and 4 columns, then 16 keys I can make it out. So, by looking at 16 keys with the 4 rows and 4 columns, I should be in a position to make it, the rows will be connected to one port and the column should be connected to other port. Based on that only I can make it. So, this is an example for making a 4x4 keyboard. Just see that the VCC is connected over there, and the input port is your port 2 and the output port is your port 1. Now, the 4x4 grid is there. This is the row lines, this is a column line, where these two are interconnected with a key press. If I am pressing this, then you will find that these two lines are getting shorted. Otherwise, these two lines are not connected. It looks like a grid. It never touches, rows and columns never touches, unless otherwise it has been pressed. So, if I am sending a VCC over here and this gets grounded and nothing is getting connected, nothing is pressed in the sense, now no voltage is ground, no voltage is going to ground, because these are all aloof, all the 4. So, I will get a 1 1 over there, because of VCC is over there, I will get a 1 1 over there, unless otherwise no key is pressed over there. If I am pressing this particular key, then these two lines are getting shorted. So, this line is grounded. If I am grounding it, then I will be receiving a 0, the voltage will go to ground, so that I will be receiving a 0 over there. All other places it is 1. So, by looking at, if I am getting a 0 over there, then I will find out that any one of the key is pressed. So, by identifying from which column it is getting pressed, in which column I am getting a 0. Based on that, I will find out that from which column I will get a key press. So that is the way, and with the rows also, that is the way it has been done, so that the rows is also identified. So it shows that port 1 is output port, port 1 is input port, and it is only a 4x4 for given keypad given for demo. So key scan, how we will be doing it? The key scan is, if the key pressed, the controller grounds all the rows by sending a 0 to the port, then it reads the column. If the data from the columns D0 to D3 is 111, then no key is pressed. If any one bit is 0, then it indicates that any one of the key is pressed, so that the voltage is grounded through that particular key pressed short, so that I am getting a 0 over there. For example, if I am saying that 110, then column 0 is getting pressed. If I am getting 1101, then column 1 is getting pressed. Now our next thing is to identify that if I am finding it the column, you just see that I can say that the column is pressed, but I need to identify for the exact key which row is pressed. So that only by identifying what is the row and what is the column which intersects at one point, so that I will find out which is the key is pressed. So to find out which key is pressed, first we have to take the first row, then it grounds that particular row and it reads the ports. Now I am sending a data, now I have grounded this row 0, now I will find out that in the port 2 whether I am getting a data or not, data in the sense 11 or not. If no key in that row is activated or pressed, then I will be getting all the things are 1. Then I will go towards the next row, it gets grounded, then I see that is there anything is received. If I am saying that any one is getting a 0, then we will be in a position to understand that that particular row is getting, in that row only I am getting, the key is getting pressed. So by identifying the row and the column together, I should be in a position to find out which is the key is pressed. So example is, if I am finding out that if D3 to D0 is 1101, then I will say that in the row, the D1 is the place where the row is getting pressed. D3 to D0 with the column, if this is 0, then row 1 and column 3 is pressed. So I can identify key 6 is pressed. If I am, this is another example, with the row I am getting 1011 and with the column I am getting 011, then I can identify that row 2 and column 3 is getting pressed. That means I can say that it is a key B is pressed. This is the way to identify which key is pressed with the matrix given in the keypad, where the rows are connected to one port and the columns are connected to one port. By looking at scanning on the column, after that scanning on the row, which makes us to identify which key is pressed. So now you just see that this is the program with which I will be in a position to find out how I will be able to trace which is the key is pressed. Now you just see this is an assembly code where move P2 0FF. So make P2 an input port. Now I am making that P2 is the, I am considering that P2 is the input port by giving it 0FF. Now I am grounding all the things by sending P1 is 0, so that first initially I wanted to make that nothing, before starting the key press has to be identified, I have to make it everything to be cleared first. So because of that I am sending a 0 to P1, then read all the columns, all the keys are, I have to ensure that the key is open or not. So because of that I am sending the P2 to A, and the A data is ANDed with 001111. So which in turn this 4 upper nibble is getting masked because of this is 0. We will be reading only these 4 pins, so that these part is getting discarded by making it ANDed with the 000 in the upper nibble, and the lower nibble is 1111. Now CJNE A, 0011 come with whatever be the data which is available with your A. If both the keys, all the keys should be released. Till then I have to wait at this particular one. If something is pressed wrongly, that also has to be released. Because of that I am putting it in a loop. It will go to K1, so I am rotating here and here indefinitely till I am getting that all the keys are released. Now I am making it initial condition, everything is getting cleared. Now I am ready for receiving which key has to be pressed. So now I am making it move A comma P2, so that I will be looking at any of the keys pressed. So ANL with A0011B, so that the 4 bits are masked. We will be looking at only the lower bits. Now CJNE A comma hash 0001111B, which gives that is that any key is pressed or not. If any of the key is pressed, then this and these two will not be same. That means any one key is pressed, any one of the bit becomes 0. If that is the case, these two will not be similar. So comparison fails, that means not equal. So I will come to over. So this is nothing but I am checking that is there any key is pressed. Yes, then I am coming to over. If it is not so, again I will go to K2, so that it gets repeated again and again till a key is pressed. If one key is pressed, I will come to this particular routine where first I will call the delay to make that I just wanted to give a debounce time for my key pressed. So 20 milliseconds I will make a delay, so that I will give a keyboard to settle, key pressed is settled. Then the P2 is whatever be the data which we read it at the port 2 is moved to A, and the A content is ANDed with 0011B. Now CJNE 00111, again I am checking that is there anything is not pressed, find the row. Okay, so for that particular reason I am checking it. If something is different, any one is 0, then I will go to find row, that means over 1. If it is not so, if it is key is not pressed, again it has to come over here, it has to go through all these rotation. If something is pressed, definitely these two will not be similar. So these two are not similar, so I will go towards over 1. So over 1 is a place where I am just checking that move P1 comma hash 11110. That means I'm just making that the row 0 is 0. I am grounding it. Now I am just moving this P2 to A, and I am just ANDing it with A comma hash 0011, so that I am masking these bits and I will be looking at only these bits. Now CJNE A comma 00011B, that means row 0. So if I am finding it that if it is row 0, then I have to proceed in that particular one. If I am not, these two are not equal, then I have to go, if these two are not equal in the sense it gets pressed, because all are 1, but this is 0, it is getting pressed. So I have to go to row 0. If it is not so, then I have to check that whether it is a second row or not, row 1. So because of that, move P1 11101, that means row 1 is checked. P2 is whatever be the red information is moved with A, it gets CJNE. If it is different, then I have to go to row 1. That way I just find out whether row 0 or row 1 or row 2 or row 3 is found. It is coming to the corresponding rows. So now if I am thinking that I have come to row 0, that means I am finding that the last row I am getting a 0. Now I have to find out which column it is pressed. So because of that, first I will be looking at move DPTR hash code, code 0. So what I am just looking at over here is for the row 0, I have a memory where I have given a data stored is 0, 1, 2, 3. So 4 keys are stored over there. For the code, the row 1 with this address 4, 5, 6, 7 is stored, and that way all the 16 keys are stored with this particular address. So now I am just looking at that DPTR content, whatever be the code 0, the address is moved to DPTR. Now I wanted to find which is the key pressed. So I am coming over here. So in this particular find, I am just making it, I am reading the data at my A, I have rotated right, and I will be checking that is there any carry is there. If no carry is there, then that is the bit it has been will be getting it. If it is not so, there is a carry is there, then that key is not pressed. Then increment DPTR and SGEM find. So that is the way I am just rotating each and every time, and each time I am incrementing it. When I am finding it there is no carry, then I found that is the thing. Then I have to, if I am JNC not carry, then I will come for match. There I will clear the A, and I will move whatever be the content of DPTR at DPTR to A. Now that A is given to P0, which the P0 will display the pressed key. So, and again I will be rotating it from the beginning, L jump K1 is starting. So, that is the way each and every row, if I am looking at row 1, I will come over here, I will find out the address of this particular one, I will go over there, I will rotate it. If any one of the bit is pressed, then the carry will be 0. So, no carry is there, then match is fixed. The address is already known by making it, the DPTR has that particular one. I found what is that particular key pressed, then that will be moved to P0, and which in turn displays that particular one. So, this is the way the key pressed is identified by the 8051 using this kind of coding. So, this is the way the input is interfaced, keyboard is interfaced with your 8051 controller. So, in this lecture we have discussed the LCD for outputting, that means for displaying, and we have discussed how we have interfaced the LCD with the 8051 and how we will be displaying it, what will be the character we wanted to display it through assembly code. And at the end we have discussed about the keyboard, how it has been interfaced with the 8051, and how we will be interpreting which is the key pressed in the keyboard is read by the 8051 through an assembly code. So, all these things which you can refer with this book. Thank you.